Tonight, we are going to talk about a kind of distance that cannot be crossed with engines, speed, or even light itself. The distance between the human mind and the true age of the universe. 100 years can feel like an entire world to us, because it is almost more than one life can hold. But the universe measures time in billions of years, in stars that burned before Earth existed, in planets shaped from ancient dust, and in a future so long that the age of starlight may only be the first chapter of a darker story. From where we stand, the night sky can look calm and permanent. But every light above us belongs to a temporary moment inside a timeline far larger than anything humans were built to understand. So tonight, the question is simple. How old is the universe really, when time itself becomes too large for the human mind? Before we begin tonight's journey, subscribe if you want more calm space documentaries like this. Leave a like if you enjoyed deep space mysteries, and write in the comments where you are watching from and what time it is right now. Tonight, you are watching the Space for Sleep channel, talking about cosmic time, the age that breaks the human mind. We begin with one of the simplest illusions in human life, the feeling that time is something we understand. Every day, we watch it move, we see the sun rise and sink, we feel the hours pass through light, hunger, tiredness, memory, and sleep. We measure our lives in mornings, birthdays, seasons, and years. And because these patterns repeat, time begins to feel familiar. It becomes part of the background, something ordinary enough to ignore. But that feeling is only possible because our lives are so small. Human time is built around the scale of a human body. A minute can feel long if you are waiting in silence. An hour can feel long if you are afraid. A year can feel huge when you are young, because it can change almost everything about who you are. Even a few decades can feel like an entire universe of memories, because inside one lifetime, there is enough change to make the past feel like another world. But the universe does not move on this scale. The universe does not care about birthdays, centuries, civilizations, or the slow rise and fall of human empires. It has its own rhythm, and that rhythm is so large that our ordinary sense of time collapses almost immediately when we try to follow it. 1,000 years, which is longer than most countries have existed in their present form, is almost nothing. 1,000,000 years, which feels impossible to hold in the mind, is still only a small step. Even 1,000,000,000 years, a number so large that it begins to lose its meaning, is not enough to describe the full story. Cosmic time is not just long. It is different. It stretches so far behind us that Earth itself becomes young. It stretches so far ahead of us that even the stars begin to look temporary. And somewhere between those two directions, the human mind is forced to face a strange truth. We live inside a universe whose real timeline was never made to fit inside human imagination. This is why cosmic time can feel more unsettling than cosmic distance. Distance is at least something we can picture. Even if the picture is imperfect, we can imagine traveling farther and farther from Earth, past the Moon, past Mars, past Jupiter, past Neptune, until the Sun becomes a bright star behind us. We can imagine crossing interstellar space, even if the journey would take longer than any human life. Distance has direction. It gives us the feeling of movement. It lets us pretend that if we only had enough speed, enough fuel, enough technology, we might someday cross it. But time is harder. You cannot turn a spacecraft toward the past. You cannot accelerate your way back to the formation of Earth. You cannot stand beside the first stars as they ignite, or wait calmly until the last stars fade, because these moments are separated from us by lengths of time that make our entire species feel like a brief flicker. Time does not sit in front of us like a destination. It surrounds us, carries us, and erases everything slowly enough that we often do not notice it happening. And yet everything in the universe is trapped inside it. Every planet is temporary. Every star is temporary. Every galaxy, even the largest and brightest, belongs to a chapter that will not last forever. The universe is not a still place filled with permanent things. It is a vast process, unfolding so slowly that from our point of view it can look frozen. But it is not frozen. It is aging. The strange part is that the universe does not look old when we look up. The night sky seems alive with light. Stars burn quietly above us. The moon appears familiar. The Milky Way, if we see it from a dark place, seems like a pale river that has always been there. Nothing about the sky tells our instincts that we are looking at ancient fire, ancient dust, and ancient history. A star can appear as a small white point, soft and peaceful, even though the light from that star may have traveled for decades, centuries, or thousands of years before entering our eyes. We do not see the universe as it is in one single present moment. We see layers of time arriving together. This is one of the first ways cosmic time begins to break the human mind. When you look at the sky, you are not looking at a single now. You are looking at many different pasts stacked above you. The moon is only about a second away by light. The sun is about 8 minutes away. Some of the stars you see with your eyes are tens or hundreds of years away in light travel time. Deeper objects, seen by telescopes, may show us galaxies as they were millions or billions of years ago. The sky is not just space, it is time made visible. And once we understand that light takes time to reach us, we begin to realize that the universe has been carrying information across darkness for longer than human beings have existed. A beam of light can cross space silently, while entire species appear and disappear below. It can begin its journey before the first humans walk upright, and arrive tonight above a city full of people unaware that an ancient message has just reached them. Right now, on Earth, we live inside seconds. We answer messages, lock doors, cook food, sleep, wake up, and worry about things that may matter deeply to us. And they do matter, because human life is lived from the inside. But above us, time is operating on a scale so enormous that the entire recorded history of our species is almost invisible. All our languages, cities, wars, songs, buildings, machines, and memories occupy a very thin layer near the surface of time. If the age of the universe were stretched across a long road, human civilization would not be a city on that road. It would not even be a village. It would be something closer to a footprint near the very end. A mark so small that a person walking past might never notice it. This does not make human life meaningless. It makes the universe larger than the meaning we usually carry with us. And that is where the feeling becomes difficult. The human mind is not naturally built to think in billions of years. Our brains evolved to understand danger in front of us, food nearby, weather changing, faces, voices, paths through forests, and the passing of seasons. We are good at recognizing patterns that help us survive on a planet. We are not naturally good at holding 13.8 billion years in our imagination. We can say the number, we can write it down, but understanding it is something else. A billion years is not just a large amount of time, it is a world-changing amount of time. It is enough time for mountains to rise and wear away, enough time for oceans to open and close, enough time for continents to drift into new shapes, enough time for life to transform so completely that the creatures at the beginning of the interval would seem almost alien to the creatures at the end, and the universe is older than 13 of those. This is why simply saying that the universe is about 13.8 billion years old does not create the proper feeling. The number is too clean. It sounds like information, not reality. It sits in the mind the way a date sits in a textbook, but behind it is a history so long that almost everything humans call ancient belongs to the final blink. The pyramids are ancient to us. The first cities are ancient to us. The earliest cave paintings feel almost impossibly old, but compared with Earth, they are recent. Compared with the sun, they are almost nothing. Compared with the universe, they are less than a breath. This is not easy to accept, because human history feels heavy. It is full of detail. We can walk through ruins and feel the weight of centuries. We can touch stone shaped by people who died thousands of years ago and feel the distance between their world and ours. That distance is real. But cosmic time places that entire feeling inside something much larger. Something that does not notice the difference between 1,000 years and 10,000 years the way we do. To the universe, almost all of human history happened at once. Not literally, but from the scale of stars and galaxies, it is close enough to feel that way. The first farms, the first kingdoms, the first telescopes, the first rockets, and the first images of distant galaxies all appear near the same tiny edge of the timeline. We are living at the far end of a story that began long before Earth had oceans, long before the atoms in our bodies had settled into a planet, long before there was a human mind to wonder about any of it. Even the era we live in has a name that sounds almost too ordinary for what it means. We live during the age of stars, the time when the universe still has galaxies filled with burning suns. To us, this seems like the normal universe, because it is the only one we have ever known. But in the full timeline, this bright age is not guaranteed to last forever. Stars form from gas. Stars burn their fuel. Stars die. Over very long times, the raw material for new stars becomes harder to gather, and the universe slowly moves toward a future with less light. That future is so distant that it feels unreal. But the same could be said about the past before Earth. It also feels unreal, yet it happened. There was a time when our planet did not exist. There was a time when the sun did not exist. There was a time when the Milky Way was still building its long history from older gas, older stars, and older cosmic structures. The world we know is not the foundation of the universe. It is a late arrival. If distance makes us feel small, time makes us feel brief. And being brief is a different kind of smallness. A tiny object can still imagine moving through space. A brief moment cannot make itself longer. It can only appear, exist, and pass into the next moment. This is why cosmic time has such a strange, emotional weight. It does not simply tell us that the universe is vast. It tells us that everything we know is happening inside a vanishingly thin slice of a much larger timeline. And yet this late arrival is the only place from which we can think about the whole story. That is the strange contradiction. The universe is ancient beyond our instincts, but it has produced beings who can notice that age. We are brief, but we can measure deep time. We are fragile, but we can look back toward the beginning of the cosmos through light that has traveled for billions of years. We cannot survive cosmic time, but for a moment, we can understand that it exists, or at least we can try. Because every attempt to understand it eventually runs into the same wall. The numbers grow too large, the comparisons stop working. The mind tries to shrink billions of years into something familiar, but the scale refuses to become human. We use calendars, clocks, timelines, and metaphors, because without them, cosmic time is almost shapeless. It is too wide to hold directly. Temporary does not mean short from our point of view. It means finite. And the universe is filled with finite things that last so long they look eternal to us. This is where cosmic time becomes both calm and frightening. It does not rush. It does not attack. It does not need to be dramatic. It simply continues. It turns young planets into old planets. It turns stars into remnants. It turns bright regions of space into quiet ones. It gives matter enough time to build worlds and enough time to erase them. Its power is not sudden. Its power is patience. A human disaster happens quickly. A cosmic ending can take billions of years. But slowness does not make it less real. In fact, Slowness is part of what makes it so hard to face. We are built to fear what moves toward us. A storm on the horizon, a fire spreading, a shadow in the dark. But the deepest changes in the universe do not move on human time. They are too slow to trigger instinct, too enormous to feel directly, and too distant to place inside ordinary fear. So they become something else, a quiet kind of dread, the feeling of standing inside a story so old and so long that the present moment feels almost impossibly thin. That thinness is where this journey begins. Before we can understand the age of Earth, the lifetime of the sun, the first stars, or the dark future waiting beyond the age of light, we have to begin with ourselves. We have to begin with the scale that makes all of this so difficult in the first place. The small, intense, fragile scale of one human life. Because to understand why cosmic time breaks the human mind, we first have to understand why even a single lifetime can feel so long from the inside. This is why cosmic time is so difficult to feel, even when we can say the numbers out loud. 100 years sounds simple. It fits into a sentence. It can be written with 3 digits. It can be placed on a timeline, marked between one date and another, and understood as a human life, a family story, a century of cities changing, wars ending, buildings rising, and old photographs fading into memory. To us, 100 years is not small. It is almost too much. It is longer than most of us will ever live. It is long enough for a child to become a grandparent, for entire neighborhoods to vanish, for languages to shift, for countries to change their borders, and for everything that once felt permanent to become something people only read about. The human mind does not begin with the universe. It begins with a heartbeat, a body, a room, a voice, a face, a morning, a night, a season. We understand time because we watch things change around us. A day feels real because the light moves across the sky. A year feels real because summer becomes winter and then becomes summer again. A decade feels real because children grow taller, older people move slower, and the world begins to look slightly different than it did before. Human time is built from things we can notice. But cosmic time is not built for noticing. It is built from changes so slow that they would appear frozen if you stood beside them for your entire life. A mountain can look eternal to someone who only sees it for a few decades. A coastline can seem fixed, even while the sea is slowly cutting it apart. A star can look like a permanent point of light, even though deep inside it, fuel is being consumed every second. The danger of time at cosmic scale is not that it moves quickly. It is that it moves with such terrifying patience that the human mind mistakes motion for stillness. This is why the age of the universe does not feel real in the way a human lifetime feels real. We can hear that the universe is about 13.8 billion years old, and for a moment, the number sounds impressive. But then, the mind protects itself. It turns the number into a label. It becomes a fact, not a feeling. It becomes something stored beside other large facts. The distance to the moon, the size of Jupiter, the number of stars in the Milky Way. We know it, but we do not carry its weight. To understand why, we have to start with the scale we were made for. 1 second is easy. It is a blink, a breath, a step, the short gap between a question and an answer. A minute can feel short or long depending on what is happening inside it. An hour can be measured by a meal, a walk, a conversation, a quiet part of the night when the house is still. A day is the first true unit of human existence because it repeats in a way the body understands. Wake, light, movement, hunger, darkness, sleep. Even before clocks, humans lived inside the rhythm of one turning Earth. A month begins to stretch the mind a little more, but it still belongs to us. The moon changes shape. Plans are made and forgotten. A year is larger, but still familiar, because the planet gives it a visible form. The seasons tell us where we are in the orbit. We know what a year feels like because the world around us changes texture, temperature, and color. Then time begins to escape. 10 years is already strange. It is short when looking back, but long when looking forward. It can erase friendships, change a face, turn a child into a teenager, and make an old version of yourself feel like a different person. 20 years is long enough for a generation to grow into the world with memories you do not share. 50 years is long enough for cities to be rebuilt, technologies to appear normal that once would have looked impossible, and people who shaped your early life to become stories. 100 years feels enormous because it almost reaches the edge of direct human memory. It is possible, in rare cases, for a person to touch a full century. A living human can become a bridge between two worlds, one before certain inventions, before certain wars, before certain maps, and one after them. That is why a century feels powerful. It is not just a number, but the universe does not notice a century. 100 years is less than a flicker on the surface of a star. It is too short for the shape of a galaxy to visibly change. It is too short for continents to move by more than a few meters. It is too short for most cosmic processes to reveal themselves without instruments, mathematics, and long chains of evidence. In 100 years, the sun looks almost exactly the same. The stars keep their familiar patterns. The moon remains close enough to seem unchanged. The night sky gives us the illusion that we are living under something stable. We think time is something we experience directly, but we mostly experience change. When change is fast enough, we feel time clearly. When change is too slow, time becomes invisible. A child growing up tells us time has passed. A star aging does not, because the star gives us almost the same face night after night. We can live our entire lives beneath the same constellations and feel as if the sky has been waiting for us. But the sky was not waiting. It was simply changing too slowly for us to notice. This is why the human mind can understand a clock, but struggles with geology. It can understand a calendar, but struggles with deep time. It can understand an old building, but struggles with a planet that existed for billions of years before the first human breath. The farther time moves away from the human body, the more it becomes an abstraction. We can say the words, but the experience vanishes. Think about the difference between 1 year and 1 million years. 1 year is a cycle. It has seasons, holidays, memories, beginnings, and endings. 1 million years has no human shape. It is not just many years placed together. It is a time span so large that the things humans use to mark existence begin to disappear. Names vanish, cities vanish, languages vanish, nations vanish. The difference between a person and a myth becomes meaningless. Even the ruins that seem ancient to us would struggle to survive unchanged across that kind of time. And yet, 1 million years is still tiny compared with the age of Earth. This is where the mind begins to lose its grip. The numbers grow too large, not because we cannot count them, but because they no longer connect to anything the body knows. 1 million years is not a longer version of a lifetime. It is enough time for climates to shift, ice sheets to advance and retreat, species to evolve, landscapes to be carved and buried. It is long enough that the world itself becomes a moving thing, not a stage. The problem is not just size, it is compression. When we hear 4.5 billion years, we often picture a long line with the present at one end and the formation of Earth at the other. That image helps, but it also lies. A line can make deep time look clean and simple, as if everything is spread out neatly. But the real feeling is stranger. Most of Earth's story happened without anything human, without cities, without animals, without forests, without oxygen-rich air in the way we know it. For most of its existence, Earth was not a world waiting for us. It was a changing planet beneath an empty sky, shaped by impacts, volcanoes, oceans, chemistry, and forms of life so small they left almost no visible trace. Human history is not the center of that timeline. It is a thin layer at the very end. This is where cosmic time becomes quietly frightening. It does not threaten us like an asteroid or a black hole. It does not rush toward us. It simply reveals that the scale of our lives is far smaller than our instincts suggest. Everything we call ancient is usually very young. The oldest pyramids, the first cities, the earliest writing, the oldest human stories that still survive, all of them belong to the last tiny edge of planetary time. They feel ancient because our memory is short. And our memory is short because it has to be. A human brain is not designed to carry billions of years as a lived experience. It is designed to remember danger, faces, paths, food, seasons, voices, patterns, and the near future. It is designed for survival inside a world of days and years. To that brain, a century is already vast. 1,000 years is legendary. 10,000 years is almost prehistoric. 1,000,000 years is fog. 1,000,000,000 years is not really understood at all. We can build instruments that measure it. We can study rocks that preserve it. We can calculate the age of stars and galaxies, but emotionally, we remain creatures of short light. This is why a calm night sky can hide something so unsettling. When you look up, you are not just looking outward into distance. You are looking into timescales that do not care whether they can be understood. Some of the light entering your eyes has crossed space for years, centuries, or much longer. Some stars you see are young compared with Earth. Others belong to older generations of the galaxy. The sky is not a single present moment. It is a mixture of different times arriving together, quietly, above your head. And even that is only the beginning, because the stars themselves are temporary. The human lifetime feels long because it is all we have. It contains every memory, every fear, every hope, every place we will ever stand. To a person, 70 or 80 years can hold an entire universe of meaning. But to the actual universe, it is almost nothing. Not because it has no value, but because the universe operates on clocks that are almost impossible to imagine. A star can burn for millions, billions, or even trillions of years, depending on its size. A galaxy can take hundreds of millions of years to rotate once. The slow drift of continents can rearrange the surface of a planet over spans that make all recorded history look like a brief spark. The cooling of a dead star can continue across time so long that the present age of the universe becomes only the early part of the story. This is the part that quietly breaks the human mind. Time is not evenly meaningful to us. We care deeply about minutes when we are waiting for news. We care about years when we are growing older. We care about centuries when we talk about civilizations. But the universe keeps going beyond the point where our categories stop working. It does not slow down so we can follow it. It does not divide itself into human chapters. When we speak about cosmic time, we are trying to place a human voice inside a timeline that began before Earth, before the sun, before the elements in our bodies were gathered into a world. We are trying to understand a universe that spent most of its history without us and will almost certainly continue for unimaginable ages after us. That does not make human life meaningless. It makes the scale around it almost unbearably large. And yet, this is exactly why time may be more difficult than distance. Because 1,000,000,000 years is not just a long time. That thought changes the way the present feels. The world around us seems immediate because we are inside it. The ground feels solid. The sky feels familiar. The sun rises with such regularity that it becomes easy to forget it is a star with a finite life. The moon hangs above us like a permanent companion, even though it is slowly drifting away. The constellations seem fixed, even though their stars are moving, aging, and eventually will no longer form the patterns we know. Everything around us is temporary, but human time is too narrow to show the motion clearly. So we live in a strange middle ground. We are intelligent enough to measure timescales we cannot feel, but not built to experience them directly. We can learn that Earth is billions of years old, but we still wake up into a single morning. We can know that the sun will change in the distant future, but we still feel its warmth as something stable and ordinary. We can understand that the universe had a beginning, but we still struggle to imagine a time before stars, before planets, before anything familiar existed. And this is where the next part of the journey begins. If a single human lifetime already feels enormous from the inside, then the age of Earth becomes almost impossible to hold. Our entire species appears only near the end of a planetary story that had already been unfolding for billions of years. Long before any human looked at the sky and wondered about the stars, Earth was already changing, burning, cooling, flooding, freezing, breaking, and rebuilding itself in silence. To feel cosmic time more clearly, we have to leave the scale of human memory behind and step backward into a world that existed before history, before language, before animals like us, and before anything on Earth could look up and call the universe old. And once a human lifetime begins to feel small, the next step is even harder. We have to look at the world beneath our feet and understand that almost everything familiar about it is recent. The cities, the languages, the oceans we name, the borders we draw, the roads, the lights, the sound of human life spreading across continents, all of it belongs to the very last thin layer of Earth's story. It feels ancient to us because we live inside it. A ruined temple can feel unimaginably old. A stone tool can feel like a message from the beginning of time. A fossil can feel as if it has fallen out of another universe. But Earth was already old before any human hand-shaped stone, before any voice spoke a word, before any eye looked up at the stars and wondered what they were. The planet had already spent billions of years turning in sunlight, cooling, breaking, drowning, freezing, burning, and changing long before there was anyone here to notice. This is one of the quiet shocks of cosmic time. The Earth does not begin with us. It does not even come close. If the entire history of Earth were compressed into a single day, modern humans would arrive only in the final moments before midnight. Our cities would appear almost at the last instant. Written history would be only a flicker. The long rise of civilization, which feels so vast from the inside, would be almost too brief to see. For most of Earth's existence, there were no people, no mammals walking through forests, no birds crossing the sky, no flowers opening in sunlight, no trees, no grass, no familiar coastlines, no continents shaped the way we know them today. There was only a planet becoming itself, slowly and violently, through a kind of patience that feels almost alien. The Earth formed around 4.5 billion years ago, from dust and rock left behind after the birth of the sun. But even that sentence is too clean. It makes the beginning sound gentle, as if the planet simply appeared. In reality, the early Earth was built through collisions. Small bodies crashed together. Rock melted, metal sank inward. The surface was not a blue world yet, and not a home. It was a young planet, still recovering from its own creation. For a long time, Earth would have looked nothing like the world we recognize. There may have been oceans of molten rock across parts of its surface. The atmosphere was not the calm, breathable sky we know now. The ground was unstable, the heat enormous, and impacts from leftover debris was still part of the planet's reality. The solar system itself was young, crowded, and dangerous. Scientists think that early Earth was struck by a Mars-sized body, often called Theia. The collision was so violent that huge amounts of material were thrown into orbit around the planet. Over time, That material gathered together and became the moon. We do not know every detail with certainty, but the evidence suggests that our moon was born from catastrophe. After the moon formed, Earth still had to become habitable. It had to cool. Its surface had to solidify. Water had to gather. The first oceans had to appear. The atmosphere had to change. And none of this happened quickly in a human sense. It unfolded across spans of time longer than every empire, every species of human, and every memory our civilization has ever preserved. Still, even with oceans, Earth was not yet a world made for us. The early atmosphere lacked the oxygen animals depend on. The sky may have looked different. The continents were not arranged into anything like the maps we know. The planet was alive geologically, but not yet alive in the familiar sense. Then, somewhere in this ancient world, life began. We do not know exactly where. It may have begun near hydrothermal vents on the ocean floor, where heat and chemistry created strange environments far from sunlight. It may have started in shallow pools or in other settings we have not fully understood. But evidence suggests that life appeared very early in Earth's history, possibly more than 3.5 billion years ago. For billions of years, Earth's life was mostly microscopic. There were no animals running across land, no forests, no insects, no bones, no eyes watching the horizon. The planet's living world was hidden in water and film and chemistry. Tiny organisms carried the story forward, with no drama visible from space. If you had visited Earth during much of this time, you might not have known it was alive at all. This is where cosmic time becomes almost uncomfortable. Life did not rush toward humans. It did not rush toward animals. It did not rush toward anything that looked like a destination. For billions of years, the living Earth remained simple by our standards, patient beyond imagination, changing the planet in ways no single creature could understand. One of the greatest changes came from organisms that learned to use sunlight. Through photosynthesis, some early life forms began releasing oxygen as a waste product. At first, this oxygen did not simply fill the air. Much of it reacted with iron and other materials in the oceans and crust. The planet had to be chemically transformed before oxygen could build up in the atmosphere. This process eventually led to what scientists call the Great Oxidation Event, roughly 2.4 billion years ago. Oxygen began to rise in the atmosphere, changing Earth forever. To us, oxygen feels like life. It is the invisible thing we take in without thinking. But to many ancient organisms, oxygen was dangerous. It was reactive. It was poisonous. For a long time after oxygen began to rise, Earth still remained very different from the world we know. Continents shifted and collided. Ancient supercontinents formed and broke apart. The climate swung through extremes. At least at certain times, ice may have spread across much of the planet, creating episodes sometimes described as snowball Earth. The exact details are complex, but the image is powerful. A living planet, wrapped in ice, orbiting the sun in silence. Volcanoes released gases, ice retreated, oceans opened, chemistry shifted, life endured. The planet kept moving through time, not in a straight line toward us, but through one transformation after another. Each stage erased the feeling that Earth had always been the world we know. For most of its history, Earth would not have welcomed us. We could not have breathed its air. We could not have survived its climates. We would not have found familiar landscapes. The planet that feels like home today spent most of its life as somewhere else. The continents are temporary. The atmosphere is temporary. The ice caps are temporary. The species covering the surface are temporary. Even the arrangement of oceans is temporary. Earth is not a finished object. It is a process moving through time. For billions of years, life remained mostly simple. Then, much later, more complex cells appeared. Later still, multicellular life became more important. Only in the last part of Earth's history did animals begin to fill the oceans in forms we could recognize as creatures. The Cambrian explosion, around 540 million years ago, brought a remarkable increase in animal diversity. But even that was late. This is the kind of number that breaks the normal rhythm of thought. If we imagine Earth as an old book, then most of the pages pass before animals appear in any familiar way. Humans do not appear near the beginning of the story. We do not appear halfway through. We appear almost at the edge of the final page that has been written so far. The dinosaurs feel ancient to us, and they are ancient compared with human history. They ruled the land for more than 150 million years, a span so long that it makes our civilization almost vanish. But even the dinosaurs were late arrivals. Earth was already billions of years old before the first dinosaur walked under the sun. The planet that produced humans is not one world, but many worlds layered on top of one another. There was an Earth before mammals mattered, an Earth before flowers, an Earth before trees, an Earth before animals, an Earth before oxygen-rich air, an Earth before stable oceans, an Earth before the moon looked as distant as it does tonight. All of these Earths are gone, but not completely. Their traces remain under our feet, in rocks, fossils, minerals, ancient sediments, and the chemistry of the atmosphere. The planet carries its memory in stone, not as a story written for us, but as evidence left behind by time. This is why cosmic time feels different from ordinary history. Human history is made of names, decisions, wars, inventions, migrations, and memories. Earth history is made of pressure, heat, erosion, chemistry, mutation, extinction, and slow movement. It is not written in years we can feel. It is written in changes too slow for a human lifetime to notice. A mountain can rise, while generations appear and disappear without seeing the motion. A continent can drift across the planet without any creature on its surface understanding that it is moving. A sea can open. A sea can vanish. Ice can advance and retreat. Species can rise, dominate, and disappear, all inside a timeline that the planet carries without hurry. This does not make humanity meaningless. It makes our moment strange. We are a very young species standing on a very old world, trying to understand a past that almost entirely happened without us. The planet beneath our feet is not young, not simple, and not built around our sense of time. It is ancient in a way that cannot be made small enough to fit comfortably inside the mind. When we say Earth is 4.5 billion years old, the number is easy to repeat. But to feel it is different. 4.5 billion years is not just a large amount of time. It is enough time for a molten world to cool, for oceans to form, for life to appear, for the air to be remade, for continents to gather and split apart again and again, for the planet to freeze, thaw, burn, bloom, and be struck by objects from space. The grass outside a house is late. The birds in the sky are late. The forests are late. The mammals are late. Human beings are almost unimaginably late. We entered a world that had already been through most of its story, then looked around and called it our beginning. From the human point of view, that makes sense. We begin where our memory begins. We build stories around the world we know. But the universe does not begin where human memory begins. Earth was already ancient before the first memory existed. It shows that our entire species is living inside a thin present, resting on top of billions of years that passed in silence. Every night sky we see, every sunrise, every shoreline, every cloud, every breath of oxygen belongs to a planet that spent almost all of its life becoming capable of this moment. The continents are still moving. The climate still changes. The core still holds heat from formation and radioactive decay. The moon is slowly drifting away. The length of the day is changing over deep time. The planet continues to evolve, not because it has a goal, but because nothing in the universe remains frozen forever. When we understand this, Earth becomes both more comforting and more unsettling. More comforting because our home is not fragile in the shallow sense. It has survived impacts, ice ages, volcanic ages, mass extinctions, and transformations beyond anything civilization has experienced. More unsettling because the version of Earth we love is not permanent. It is temporary, like every other version before it. And this current face depends on conditions that took billions of years to build: the right distance from the sun, the presence of liquid water, a changing atmosphere, a magnetic field, plate tectonics, a large moon influencing tides and stabilizing Earth's tilt over long periods, a long chain of accidents and processes that made our moment possible. The rocks below us remember a younger sun. The moon remembers a violent impact. The oceans remember a cooling world. The oxygen in the air remembers ancient microbes. The continents remember collisions. The fossil record remembers entire kingdoms of life that rose and vanished before humans were even possible. And behind all of it is the same uncomfortable truth. Earth is old, but it is not isolated from time. Its age is tied to the age of the solar system, and the solar system is tied to the life of the sun. The planet's history is enormous compared with us, but compared with the sun, Earth is part of a larger clock. The same sun that warmed the early oceans, powered ancient life, and rose over every vanished world in Earth's past, has also been aging the entire time. It has not been a fixed lamp in the sky. It has been changing slowly, steadily, invisibly to human eyes. Our sun is not young anymore. By the time Earth had cooled enough to carry oceans, continents, weather, and eventually life, the sun had already been burning for longer than the human mind can hold. That is difficult to feel, because the sun does not seem ancient in the same way a fossil seems ancient, or a mountain, or the bones of an extinct animal. The sun feels immediate. It rises every morning with such certainty that we almost stop thinking about it. We measure our days by it, our seasons by it, our years by the path Earth takes around it, and its presence feels less like an object in space and more like a rule of reality. But the sun is not a rule. It is a star, and like every star, it had a beginning. About 4.6 billion years ago, before Earth had oceans, before there was a moon shining over any night, the material that would become our solar system was scattered as gas and dust inside the Milky Way. Hidden inside that cloud were the ingredients of everything familiar: the future sun, the future Earth, the future oceans, and the atoms that would one day become living cells and minds capable of asking where all of it came from. Then gravity began to gather the cloud inward. There was no complete solar system appearing all at once. Just a slow collapse across a scale too large to picture. Gas fell inward. Dust followed. The center grew denser and hotter. Around it, leftover material flattened into a spinning disk, and inside that disk, the planets began their long formation. But the center came first. Before Earth was Earth, the sun was becoming the central engine of everything around it. This changes the way the solar system feels. We often imagine it as a collection of planets, with the sun placed in the middle like a lamp. But the sun contains almost all the mass of the solar system. The planets are the smaller leftovers of the same birth process. Earth is not separate from the sun's story. Earth is a later chapter inside it. Every ocean, continent, extinction, forest, animal, human, city, and telescope has existed under a star that was already ancient long before any of those things appeared. The sun warmed the early Earth when the surface was violent and molten. It shone over the first oceans before anything swam in them. It shone over a planet with no birds, no mammals, no flowers, no forests, and no people. It was there through the long silence before life became complex, through the rise and fall of creatures that disappeared hundreds of millions of years before humans. And today, When sunlight touches your skin, it comes from that same star. This is one of the quiet ways cosmic time becomes unsettling. The sun feels like the present moment, but it carries the entire past of Earth inside its light. It has been there for almost every version of this planet. Not because it watches, or chooses, or cares, but because it burns steadily enough for the planet around it to change, while the star seems almost the same. Almost. From a human point of view, the sun looks perfectly stable. One lifetime is far too short to notice its deeper evolution. Even all of recorded history is too short. Across thousands of years, the sun rises, sets, returns, and appears unchanged. But on its own timescale, the sun is slowly transforming. Deep inside its core, hydrogen is being fused into helium. Matter is being converted into energy. The star is spending its fuel, not violently, not quickly, but constantly. Every second, the sun turns millions of tons of mass into energy. That sounds dramatic, but the strange part is how calm it looks from Earth. There is no visible countdown in the sky. The same process that makes the sun stable is also the process that slowly moves it through its life. It survives by changing. It shines by consuming what is inside it. And because that change takes billions of years, it can feel eternal even while it is temporary. The sun is roughly middle-aged. That phrase is almost too familiar for something so huge. But for a star like the sun, it means something difficult to absorb. It has already been shining for about 4.6 billion years, and it may continue its long, stable phase for roughly another 5 billion years before its deeper transformation begins. To us, that future is almost indistinguishable from forever. No person alive today will see it. No monument will last until then. No language spoken now will survive unchanged across that distance. But to the universe, the sun is not just beginning, it is already well into its story. This matters because the sun is the foundation beneath almost everything Earth has become. It drives the climate, powers the water cycle, feeds plants through photosynthesis, shapes weather, moves winds, influences ocean currents, and gives life the energy it needs to build complexity. Even much of the energy humans use today is connected to ancient sunlight stored in plants and organisms that lived long before us. In a real sense, life on Earth has been living inside the temporary generosity of a star. Temporary is the important word. The sun is not kind, and it is not cruel. It is not protecting Earth. It is not planning to destroy it. A star has no intention. It simply holds itself in balance between gravity pulling inward and energy pushing outward. For billions of years, Earth has existed at the right distance to benefit from that balance, close enough to receive warmth, far enough not to be consumed by it. But cosmic time has no reason to keep that balance comfortable forever. The sun is slowly becoming brighter, not in a way a person could notice from one year to the next, and not in a way that changes the morning sky during a single civilization, but across deep time, gradual brightening matters. A small change spread over billions of years can reshape the fate of a planet. The same sun that made Earth habitable can eventually help make Earth hostile. Long before the sun reaches its final red giant stage, its increasing brightness may alter the climate, the oceans, and the atmosphere in ways that push the planet away from the conditions that allowed complex life to thrive. This is not the kind of danger humans are built to fear. A fire, a storm, an impact from space. Those feel like events. They have edges, they begin, they happen, they end. But the aging of the sun is not an event in that simple sense. It is a slow direction. It is a quiet pressure spread across ages. There may never be one clear day when Earth's comfortable era suddenly ends. Instead, the world could change so gradually that only the long record would reveal the size of what happened. A planet does not need to be destroyed in a moment to lose what made it familiar. It only needs enough time. This is why the sun is one of the best ways to understand cosmic time. It is the most familiar object in the universe to us, and yet even it belongs to a timescale that breaks ordinary thought. We know its light. We feel its warmth. We have watched it rise since the beginning of human memory. But the star itself is older than every landscape humans have ever known, and its future reaches farther than almost any story we can easily tell. The sun's life also reveals something deeper about the universe. Stability does not mean permanence. Something can be reliable for every generation that has ever lived and still be temporary. The sun has risen over every human birth, every human death, every empire, every quiet morning, and every night when someone looked upward and wondered what the stars were. It has never failed in our experience. And still, it is not eternal. It is only old. And old things in the universe still end. Eventually, the hydrogen in the sun's core will no longer support the same long balance it has maintained for billions of years. The star will change more dramatically. Its outer layers will expand. It will become a red giant, far larger and brighter than the sun we know now. Mercury and Venus are expected to be swallowed or destroyed, and Earth's exact fate is more complicated. But the planet will almost certainly become uninhabitable long before any final physical ending. The oceans, the atmosphere, and the surface conditions that make Earth feel like home will not be protected forever. The strangest part is that this future is both real and almost unreachable to the mind. 5 billion years feels meaningless to us, but it is not meaningless to the sun. It is the remaining stretch of its main life, the distance between now and the transformation of the star that defines our sky. The sun is not an extreme star. It is not one of the oldest lights in the galaxy. It is ordinary, calm, and middle-aged. The star that feels eternal to Earth is to the Milky Way, only one more glowing point in a vast population of stars, born at different times, aging at different speeds, and moving toward different endings. Some stars live fast and die young, burning through their fuel in only a few million years before ending in violent explosions. Others are small, cool, and dim, able to burn slowly for timescales far longer than the current age of the universe. The sun lives between those extremes. It is stable enough to give a planet like Earth billions of years, but not stable forever. It offers time, but not infinity. That is the difference cosmic time forces us to understand. 1 billion years is not forever. 10 billion years is not forever. Even a star's life is only a phase. When we look at the sun, we are looking at a clock with no hands visible to us. It does not tick loudly. It does not mark its passing in ways our senses can easily catch. But it is counting. Every moment of sunlight is also a moment of fuel spent. Every sunrise belongs to a star moving slowly and silently through its own lifetime. The sun also carries an older history inside it. It did not form from pure emptiness. The cloud that made the sun contained material shaped by earlier generations of stars. Hydrogen reaches back toward the early universe, but many of the heavier elements that became Earth, rock, metal, ocean chemistry, and living bodies were forged in stars that existed before our solar system. Those older stars burned, changed, and in many cases died before the sun was born. Their remains mixed into space, and some of that material became the cloud from which our star and planets formed. So the sun is ancient, but it is not the beginning. It is a descendant. That thought opens the timeline even wider. Before the sun, there was already a long cosmic history. The Milky Way was already forming and changing. Earlier stars had already lived entire lives. Some had exploded, scattering the elements needed for rocky worlds. The universe was already billions of years old before our solar system began. When the sun ignited, it did not begin cosmic time. It entered a story that was already far underway. And yet, for Earth, the sun is everything. Locally, the sun is almost absolute. Without it, Earth would be a frozen world, lost in darkness. With too much of it, Earth would become hostile. Our planet's entire living history is balanced around this one star. But on the scale of the galaxy, the Sun is ordinary. It is one star among hundreds of billions, neither the oldest, nor the largest, nor the brightest. It is everything to us, and almost nothing to the galaxy. Every morning is not just the return of a familiar light. It is a brief moment inside a stellar lifetime. Every shadow on the ground, every warm surface, every bright cloud. Every sunset is part of a process that began before Earth could support life, and will continue long after the present world has changed beyond recognition. The sun makes time visible, but only if we know how to look. It shows us that the universe does not need to rush to be powerful. It can build a star, give it billions of years of calm light, allow planets to form around it, allow life to appear on one of them, and still hold the ending so far away that the creatures living under that star can barely understand it. Cosmic time is not only terrifying because it is old, it is terrifying because it is patient. The sun is patient. It burns quietly. It changes slowly. It gives Earth enough time for life to rise, and enough time for that life to look back at the star and realize that the warmth above it is part of a much larger cycle. Birth, stability, change, expansion, fading. Not in a human lifetime, not even in all of human history, but in the deep rhythm of stars. And once we see the sun this way, the next question becomes unavoidable. If our own star is already billions of years old, and if it formed from the remains of stars that came before it, then the story of cosmic time does not begin with the solar system at all. It begins earlier, in an age before Earth, before the planets, before the sun itself, when the first generations of stars began to burn in a universe that had only recently escaped its deepest darkness. Before the sun existed, before Earth had a surface, before there were oceans, continents, or even the dust that would become our planet, the universe had already passed through an age of darkness and fire. This is where cosmic time becomes harder to hold, because the solar system already feels ancient enough. A star that has burned for 4.6 billion years pushes the mind far beyond human history. But the sun is not the beginning of the story. When our star formed, the universe was already old. Galaxies had already begun to grow. Earlier stars had already lived, changed, and died. Some of the material that became Earth had already passed through the interiors of stars that no human eye will ever see. The sun was born into an old universe, and long before it appeared, there was a time when no star had ever shone. Today, when we think of space, we think of stars. The night sky feels defined by them. Galaxies are made visible by them. Planets orbit them. Life on Earth depends on one. But the universe did not begin with a sky full of stars. For a long time after the Big Bang, there were no suns, no planets, no glowing galaxies, and no familiar points of light scattered through the dark. There was matter, there was gravity, there was radiation, there was expansion. But there was no starlight. The early universe was not empty, but it was not lit in the way we understand light today. It was filled mostly with hydrogen and helium, the simplest elements spread through space in a vast, uneven fog. Tiny differences in density became important. Places with slightly more matter pulled in more material through gravity. Over immense periods, these regions grew denser, slowly gathering gas into the first cosmic structures. Nothing about this process was quick in human terms. But compared with the later life of stars and planets, the universe was still young. Gravity was taking the almost smooth early cosmos and quietly turning it into something with shape. Then, inside some of the densest regions, the first stars began to form. They were not like the sun. The first stars were born from almost pure hydrogen and helium, without the heavier elements that later helped clouds cool and fragment into smaller stars. Because of this, many scientists think these first stars may have been extremely massive, far larger and hotter than our Sun. They may have burned with a fierce, blue-white light, living short, violent lives compared with the slow, steady lifetime of a star like ours. And when they ignited, the universe changed forever. For the first time, darkness was broken from within. The first stars began to pour light into space, not as leftover glow from the early universe, but as the focused fire of stellar cores. Their light moved outward into the surrounding hydrogen, changing the gas around them and carving bright regions inside the ancient dark. What had been a universe waiting in shadow became a universe with sources of fire. The first stars were not beautiful in the way a sunset is beautiful. Their beauty is darker and more distant. They were the first engines that began to change the chemical future of everything. Before stars, the universe had very little variety. Hydrogen and helium dominated. There was almost none of the carbon, oxygen, silicon, iron, and other heavier elements that later became planets, air, water, stone, blood, and bone. The early universe had the raw simplicity of a beginning, but it did not yet have the richness needed for worlds like Earth. Stars changed that. Inside stellar cores, elements can be forged. Stars take simple atoms and, under enormous pressure and heat, build heavier ones through nuclear fusion. In massive stars, this process can go further than it does in smaller stars. Layer by layer, deeper and heavier elements form inside them as they age. And when the most massive stars reach the end of their lives, they can explode, throwing newly made material back into space. This means the first stars were not only lights, they were factories. They were places where the universe began making some of the ingredients that later worlds would need. They lived before Earth, but Earth could not exist without stars like them. The rocks beneath our feet, the iron in our blood, the oxygen we breathe, the carbon chemistry of life. All of it belongs to a cosmic story that started long before the sun. Some of these elements came from earlier stars and stellar deaths. We cycled through space until they became part of the cloud that formed our solar system. So when we say Earth is old, we are still starting too late. Earth is made from older things. The planet is not just a world that formed 4.5 billion years ago. It is a collection of ancient matter shaped by events that came before it. The atoms inside Earth carry a memory deeper than the planet itself. Some were forged in stars before they were part of oceans. Some were scattered by explosions long before the cloud that formed the sun began to collapse. This is where cosmic time becomes intimate in a strange way. The first stars are not just distant objects in an unreachable past. They are connected to the present through matter. They are part of the reason later stars could form differently. Part of the reason planets could become rocky. Part of the reason chemistry could become complex enough for life. The universe had to age before Earth could exist. A young universe could not have made us. Life did not appear in a universe that had just begun. It appeared after the universe had already spent billions of years preparing the materials. When we look backward toward the first stars, we are not looking at a random chapter. We are looking at the beginning of the long chain that eventually made Earth possible. But those first stars are gone. That is another part of the unsettling truth. The stars that helped transform the young universe did not remain calmly in the sky for billions of years like the sun. If many of them were as massive as scientists suspect, they lived quickly. Massive stars burn through their fuel at an incredible rate. Their cores are hotter, their fusion is more intense, their lifetimes are much shorter. A star many times heavier than the sun can live only a few million years, which is almost nothing beside the age of the universe. A few million years sounds long from a human point of view. It is older than cities, older than agriculture, older than our species in its modern form. But for a star, it can be a short life. For the universe, It is barely a first breath. The first stars may have burned brightly, violently, and briefly. Then, many of them died, perhaps in powerful explosions that scattered their newly formed elements into surrounding space. Those deaths were not endings in the simple sense. They were transformations. A star died, and the material it released became part of the next generations of stars, galaxies, planets, and eventually living worlds. The universe remembers through recycling. Nothing in this story stays in one form forever. Gas becomes stars, stars make elements, stars die and return material to space. New clouds gather that material. New stars form. Planets appear in the leftover disks. Worlds cool, change, break, and rebuild. Life can rise on some of them, not separate from this cycle, but made from it. The first stars were the opening fires of that cycle, and because they are gone, we cannot see them directly in the simple way we see nearby stars. Astronomers search for their traces through the most distant light, the earliest galaxies, the chemical fingerprints left behind, and the way ancient radiation and gas changed as the universe evolved. The farther we look into space, the farther we look back in time. But there are limits. The first stars belong to a region of cosmic history that is difficult to observe, partly hidden by distance, expansion, and the faintness of the earliest light. Without that first generation of stars, the universe would have remained far poorer in the ingredients needed for complex worlds. The Sun, then, is not only a star, it is an heir. It carries the consequences of earlier stars inside the material around it. Earth does too. So does every living thing. This does not make us special in the way humans often want to be special. It makes us part of an ancient chain of matter and time. We are not standing outside cosmic history, looking at it from a safe distance. We are made from its aftermath. The first stars burned before Earth was possible, but they are connected to everything Earth became. By the time we looked up, the universe was ancient. This is why cosmic time breaks the human mind more deeply than ordinary distance. Distance tells us the universe is large. Time tells us we are late. Not late in a dramatic or tragic sense, but late in the sequence. Late enough that the materials in our bodies have already been through older stars. Late enough that the sun is middle-aged. Late enough that Earth itself carries billions of years of change beneath every step. Late enough that the first lights of the universe are not part of our sky as visible stars, but part of the deep past that made the sky possible. The first stars did not know they were first. They did not know they were changing the future. They burned because gravity gathered matter, because pressure rose, because fusion began. They lived according to physics. And yet, without their lives and deaths, the universe would not have become rich enough for later worlds like Earth. That is one of the most important truths in the whole story of cosmic time. Destruction and creation are often the same process, viewed from different distances. A massive star dies, and from nearby it may be a catastrophe, but across cosmic time, that death enriches space. It sends out material that may one day become a planet, a moon, an ocean, or a living body. The universe does not build gently. It builds through collapse, fire, scattering, cooling, gathering, and collapse again. It builds by changing everything. The first stars were temporary, and because they were temporary, the universe could move forward. This makes the night sky feel different. Every star is not just a light, it is part of a chain. Some are young, some are old. Some will die quietly. Some will die violently. Some may have planets around them. Some may one day scatter material that becomes something else. The sky is not a collection of permanent points. It is a living history of stellar time, moving too slowly for human eyes. And somewhere in that history, long before the sun, The first generation began the work of making the universe chemically alive. But they also remind us that everything luminous is temporary. The first stars did not remain. The early lights faded. Their material moved on. Later, stars replaced them. Later, galaxies brightened. Later, planets formed. The universe we see now is not the first version of the universe. It is the result of vanished fires. The sun is one of those later fires. It shines calmly now, but it belongs to the same pattern. It formed from older material. It burns through its own fuel. It gives Earth time, and one day, it too will change. It is not outside the cycle that began with the first stars. It is inside it. And so are we. By the time a human being stands under the night sky, almost all of that has already happened. We are not early witnesses. We are late products of a universe that spent most of its known history becoming capable of producing us. And even now, the process has not stopped. Stars are still forming in cold clouds of gas. Massive stars are still dying. Elements are still being returned to space. Planets are still assembling around young suns. Somewhere, perhaps, new worlds are cooling under young light, entering the same kind of long waiting period Earth once passed through. The first stars are gone, but the cycle they began continues. That is why the next part of the journey cannot stay only in the past. Because once we understand that the first stars burned and vanished before Earth was born, we begin to see every star differently. The sun is temporary. The first stars were temporary. The stars shining above us tonight are temporary. Some will outlive the sun by unimaginable stretches of time, and some will die far sooner. But none of them are frozen in place. None of them are permanent lights attached to the darkness. The universe is not filled with eternal stars. It is filled with stars at different moments in their lives, and every one of those lights is moving slowly or violently toward change. And once we understand that the first stars burned and vanished before Earth was born, the night sky begins to feel different. It no longer looks like a ceiling filled with permanent lights. It becomes something stranger, a field of stars at different moments in their lives, each one moving through time at a pace the human eye cannot follow. Some are young and still surrounded by the remains of the clouds that made them. Some are steady and middle-aged, like the sun. Some are old, swollen, unstable, or already close to the end. And some of the lights we see may come from stars that have changed dramatically since their photons began the long journey toward us. From Earth, the stars can look still. But none of them are still. They are burning, aging, drifting, changing, and moving toward futures that may be quiet, violent, beautiful, or almost invisible. The only reason they seem eternal is that human life is far too short to see their stories unfold. A person can look at the same constellation as a child, then again as an old man, and the stars will seem unchanged. Generations can pass beneath the same familiar patterns. Ancient sailors, farmers, priests, astronomers, and travelers used the stars as guides because they appeared reliable. The sky became a map because it seemed fixed. The same shapes returned each year. The same bright points marked direction. The same constellations rose and set with the seasons. But this stability is a trick of scale. The stars are not fixed. They only move too slowly for us to notice without careful measurement. Across thousands of years, the shapes of constellations shift. Across millions of years, the night sky would become unfamiliar. Across billions of years, many of the stars we know would be gone, transformed into remnants, replaced by others, or moved far from where we see them now. The sky is not a painting. It is a slow-motion event. Every star begins inside a cloud. Somewhere in the cold darkness of space, gas and dust gather under gravity. At first, the cloud may seem almost motionless, spread across light years, faint and silent. But inside it, denser regions can form. Material falls inward. The center grows hotter. A young star begins to take shape, hidden at first inside the same material that is feeding it. Around it, leftover matter may form a disk, and from that disk, planets may eventually grow. This is how a star begins. Not as a point of light already shining in the sky, but as a collapse. A star is born when gravity compresses matter until the core becomes hot and dense enough for nuclear fusion. Hydrogen begins to fuse into helium. Energy pushes outward. Gravity pulls inward. A balance forms, and the star enters the long part of its life, the phase where it can shine steadily for millions, billions, or even trillions of years, depending on its mass. But this balance is not permanence. It is a temporary agreement between opposing forces. Gravity never stops pulling inward. Energy from fusion never stops pushing outward. The star survives because those forces hold each other in check. From the outside, this can look peaceful. A star shines, a planet orbits, light crosses space. But inside, the star is always using fuel. It is always changing the composition of its core. It is always moving, however slowly, toward the next stage. That is why every star in the sky is temporary. Not temporary in the human sense. Not brief like a storm, a building, a civilization, or a life. Some stars last so long that the current age of the universe is not enough time for them to reach their endings. But temporary in the deeper cosmic sense. They have beginnings, they spend their fuel, they transform, and eventually, they stop being the kind of star they once were. The most massive stars are the easiest to understand because their lives are dramatic. They are born huge, hot, and bright. They shine with such intensity that they can be seen across enormous distances. But that brightness comes at a cost. A massive star burns through its fuel far faster than a smaller star. It may live only a few million years, a time span that sounds enormous to us, but is almost nothing compared with the life of the sun. These stars are like fires that consume themselves too quickly. Their cores become factories for heavier and heavier elements. Hydrogen gives way to helium, then to more complex stages of fusion. The star struggles to hold itself up against gravity as each new fuel source is used. Eventually, for the most massive stars, the core can no longer support itself. Collapse comes suddenly. The outer layers are blasted away in a supernova, a stellar death so bright it can outshine entire galaxies for a short time. From a human distance, a supernova can look like a brilliant cosmic event. But from the star's point of view, it is the end of a life. The star that once burned steadily is torn apart. Its material is scattered back into space. A neutron star, or black hole, may be left behind, a collapsed remnant where a giant star used to be. And yet, this violent ending is also part of the reason the universe becomes richer. The explosion sends heavy elements outward. The remains mix with gas clouds. Later generations of stars and planets can form from that material. What looks like destruction across one timescale becomes creation across another. A massive star lives briefly, dies violently, and leaves behind ingredients for worlds it will never see. Other stars die more quietly. A star like the Sun does not end as a supernova. It is not massive enough for that kind of final collapse. Instead, after billions of years of stable burning, it changes more slowly. It expands into a red giant, shedding outer layers into space. Those layers can form a glowing shell around the dying star, while the core remains behind as a white dwarf, hot, dense, small, and no longer producing energy through fusion in the same way. It simply cools, slowly, across immense time. This kind of ending is quieter, but not less final. The sun will not explode across the galaxy. It will not become a black hole. Its ending will be slower, more ghost-like. The star that now lights our day will eventually lose its outer layers, and leave behind a stellar remnant, a white dwarf fading through the dark. The worlds around it will already be changed or destroyed. Earth, if it still exists, will no longer be the living planet we know. This is what it means for a star to be temporary. Even the calm ones are moving toward transformation. Small red dwarf stars burn slowly. They are cooler, dimmer, and far less dramatic than the sun. Many are too faint to see with the naked eye from Earth. But because they use their fuel so slowly, they can last for astonishing lengths of time. Some may shine for hundreds of billions or even trillions of years, far longer than the universe has existed so far. Even these slow stars are temporary. When we look at the stars tonight, we are not seeing a single age of light. We are seeing many ages mixed together. Some stars are younger than the sun, some are older. Some formed from clouds enriched by many earlier generations. Some burn in clusters, where stars were born together from the same material. Some are giants near the end of their lives. Some are white dwarfs, already finished with their main shining phase. Some are hidden remnants that do not shine like normal stars at all. The sky blends these different stages into one calm image. That calm image is misleading. It makes the universe feel still when it is actually full of slow endings. It makes the stars feel equal when each one has its own mass, fuel, history, and fate. It makes the night seem timeless when it is really a view into countless clocks running at once. A massive blue star may be racing toward death while a small red dwarf beside it barely changes. A star like the Sunday may still have billions of years of light ahead, while another has already finished its main life and become a dense remnant. A star whose light reaches us now may have changed since that light left. The sky is not showing us the present in one simple moment. It is showing us light from different distances, different histories, and different points in stellar lives. This is why stars are also time machines. Not because they let us travel, but because their light carries the past. The farther away a star is, the older its light is when it reaches us. A nearby star may show us how it looked only a few years ago. A distant star may show us how it looked hundreds, thousands, or even millions of years ago. When we look across space, we're always looking backward. So the stars are temporary in two ways. They are temporary because they age and die, and they are temporary because the version of them we see is already old light, a message sent from a moment that no longer exists, exactly as we receive it. The night sky is not the universe as it is right now. It is a layered memory of the universe as it was. Stars do not only end individually. On the largest timescales, the entire age of star formation will change. Right now, the universe is still capable of making new stars. Cold gas clouds collapse. Galaxies continue to form stellar nurseries. Young stars appear in glowing regions of gas and dust. But this process depends on available gas. Over time, galaxies use up or lose the material needed to form new stars. Existing stars return some material to space, but not all of it remains available forever. The universe will not keep making stars at the same rate endlessly. In the far future, star formation is expected to slow. The bright age of galaxies will fade. More stars will become remnants. White dwarfs, neutron stars, and black holes will become more common compared with living stars. The universe will still exist, but it will become less filled with new light. The era that feels normal to us, the age of shining stars and glowing galaxies, is not the final state of everything. It is a phase. This is perhaps the largest meaning hidden inside a single star. The life of one star shows us the fate of many. The death of one star points toward the eventual fading of starlight across cosmic time. The sun is temporary. The stars around it are temporary. Star formation itself may be temporary. The universe we see when we look up is not eternal scenery. It is an illuminated chapter. The stars are not decorations. They are processes. They are not points. They are lives. And like all lives, they are shaped by beginnings, changes, and endings. Every star is a story told too slowly for us to watch. That is why the sky can be so calming and so disturbing at the same time. It looks peaceful because it changes slowly. It feels eternal because our lives are brief. But the calm is not stillness. It is motion stretched across time. If we could speed up the galaxy, the illusion would disappear. Stars would drift. Some would flare into brightness and die. Others would swell into giants. Some would shed glowing shells. Some would collapse into dense remnants. New stars would form in clouds of gas. Clusters would disperse. Constellations would twist and dissolve. The Milky Way would no longer look like a frozen river of light. It would look alive, with slow fire. But we do not see it that way. We see one frame. We are born into one frame, live inside it, and leave before the next frame becomes obvious. Cosmic time makes us realize that the universe is not still just because our view of it is brief. The sun gave Earth that time. But as we have seen, the sun is temporary too. But the sun's stability is not separate from the larger universe. It belongs to a galaxy with its own history. A galaxy filled with older stars, younger stars, dead stars, star-forming clouds, and remnants of violent events. The sun is one point inside that larger timeline. To understand why it formed when it did, and why Earth could form around it, we have to widen the view again. The story cannot stay only with the stars we see tonight. Because before the solar system existed, before the sun gathered its planets, before Earth became a world, the Milky Way itself had already been changing for billions of years. The galaxy had already been building the environment where our star could appear. Older generations had already enriched its gas. Stellar deaths had already seeded space with heavier elements. Long before Earth, the universe had been preparing the stage without ever knowing there would be a planet here. And that older stage is where the next part of the journey begins. Not with a star, but with the universe before our solar system was even possible. Because before the solar system existed, before the sun gathered its planets, before Earth became a world, the Milky Way itself had already been changing for billions of years. This is the part of cosmic time that quietly removes us from the center of the story. Earth feels ancient because it is older than all human memory. The sun feels ancient because it had already burned for billions of years before we arrived. But even the sun was born into a galaxy that already had a long past. The place where our solar system formed was not empty space waiting for a star. It was part of an old, rotating, evolving galaxy, shaped by stars that came before, by gas clouds that had been enriched, by explosions that had scattered heavier elements, and by gravity that had been organizing matter long before Earth was possible. The solar system did not appear at the beginning of the universe. It appeared late enough for the universe to have already become complex. When we imagine the birth of the sun, it can feel like the beginning of everything familiar. A cloud collapses, a star ignites, planets form, Earth cools, life eventually begins. But that local beginning was only one event inside a much larger history. The cloud that became the sun was not made of untouched material from the first moments of the cosmos. It was a mixture, carrying hydrogen from the early universe and heavier elements forged by older stars. It was matter with a past. This means the birth of the solar system was already an inheritance. The Milky Way had to exist first. Earlier generations of stars had to live first. Some had to die first. Their material had to return to space. Gas had to mix, cool, drift, collapse, and become part of new clouds. Only after that long chain could a star like the sun form with enough heavy material around it to build rocky planets. metal cores, silicate crusts, water-bearing bodies, and the chemistry that would eventually make life possible. The universe did not simply make Earth, it made the conditions that could make Earth. That difference matters, because it stretches the story far beyond the age of our planet. Earth is about 4.5 billion years old. That is almost impossible to feel on its own. But the universe is about 13.8 billion years old, which means that by the time Earth formed, more than 9 billion years of cosmic history had already passed. During that time, the first stars had burned and vanished. Early galaxies had grown. The Milky Way had assembled much of its structure. Countless stars had formed before the sun. Some had lived entire lives and disappeared before our star was even born. The Milky Way is not just a place, it is a history. Every region of it carries some memory of what happened there. Old stars move through the halo and thick disk. Younger stars form in spiral arms and star-forming regions. Heavy elements spread through gas clouds. Dead stars leave remnants behind. The galaxy turns slowly, carrying stars and clouds around its center across enormous stretches of time. The sun was born somewhere inside this already ancient system, not as the first light, but as one more star in a galaxy filled with previous chapters. This makes the solar system feel smaller, but also stranger. Small, because it is only one system among billions. Strange, because it depends on so much that happened before it. If the sun had formed too early in cosmic history, there may not have been enough heavy elements nearby to build Earth as we know it. A young universe can make stars, but it cannot immediately make planets like ours in the same way. It needs enrichment. It needs older stars to create and scatter the ingredients. It needs time for the galaxy to become chemically rich. This is why cosmic time does not move in a straight line from the Big Bang to humans, as if everything was waiting for us. It moves through layers. First, simple matter. Then, the first stars. Then heavy elements. Then later stars. Then planets. Then stable worlds. Then long chemical histories. Then, perhaps, life. Each layer depends on the one before it. Each one takes time. The universe had to become old enough to become interesting. That idea is difficult because we are used to thinking of old age as decline. For humans, age often means fading strength, lost youth, and approach toward an end. But in the universe, age also means accumulation. A very young universe was simpler. It had less structure, less chemical variety, fewer places where complex things could happen. Time did not only wear things down, it also allowed things to form. The solar system is a product of that accumulation. The cloud that formed the Sunday may have drifted through the galaxy long before it collapsed. It may have been stirred by nearby stars, shaped by pressure waves, enriched by previous stellar deaths, and slowly brought into the right conditions for gravity to take over. We do not know every detail of that cloud's history, but we know the larger truth. It was not first-generation material. It had been touched by the lives of older stars. When the sun formed, it did not form alone. Around it, the leftover disk became a violent nursery. Dust grains collided and stuck together. Larger bodies formed from smaller ones. Worlds grew by impacts. Some bodies were thrown away, some crashed into each other. Some became planets. Some remained as asteroids and comets. The early solar system was not a peaceful clock already ticking in perfect order. It was a construction zone made from ancient ingredients. This is one of the reasons cosmic time breaks the human mind. Beginnings are not always true beginnings. What feels like the start of a story is often only the start of a local chapter. The birth of Earth was the beginning of Earth, but not the beginning of the matter inside Earth. The birth of the sun was the beginning of our star, but not the beginning of the atoms around it. The birth of the solar system was the beginning of our cosmic home, but not the beginning of the universe that made it possible. Every beginning stands on older ground, and in space, that ground is time. The Milky Way before the solar system was already filled with stars that would never know our sun. Some of them may have been long-lived red dwarfs still shining today, older than Earth by billions of years. Others were massive stars that lived and died quickly before our system formed. Some may have ended as white dwarfs, neutron stars, or black holes. Some may have exploded and contributed material to the gas from which later stars formed. The galaxy was already full of clocks, and the sun became one more clock among them. There may have been planets before Earth, too. This does not make Earth less remarkable. It makes it part of a larger cosmic pattern. The universe may have been forming planets for billions of years before our solar system appeared. Some worlds could have lived through entire planetary histories before Earth had an ocean. Their stars may have aged, expanded, or died. Their surfaces may have frozen, burned, or changed beyond recognition. If life ever appeared on any of them, it may have risen and vanished before our planet was ready for life at all. That thought is quiet, but immense. It means that when we look backward, we are not only looking toward a universe without humans. We are looking toward a universe that may have already contained other stars, other planets, other long histories, and possibly other chances for life before Earth entered the story. We do not know how often that happened. We do not know whether life is common or rare. But the timeline allows the possibility that Earth is not the first place where complexity had time to unfold. Cosmic time does not only make us small in space, it makes us late in history. But the universe does not share that perspective. Before Earth, there were no human witnesses to the Milky Way's slow evolution. Stars formed in spiral arms without names. Gas clouds collapsed without meaning. Supernovae scattered elements into darkness. Galaxies interacted and changed. The sun's future ingredients drifted through space, mixed with other material, and waited inside clouds that did not know they would one day become a star with a living planet. That waiting was not purposeful, it was physical. Gravity gathered matter. Radiation heated and cooled gas. Stellar winds pushed material outward. Explosions stirred clouds. The galaxy rotated, regions became unstable. New stars formed when conditions allowed. The universe did not need a plan. Time and physics were enough to make complexity possible. That realization makes the solar system feel both familiar and alien. Familiar because it is our home. Alien because its foundations are older than home can normally mean. The sun, the planets, the moon, the asteroid belt, the comets in the distant darkness. All of them belong to a system that formed from a galactic past far deeper than the system itself. Even comets, those frozen bodies at the edges of the solar system, are part of this story. They preserve some of the ancient material from the early disk, carrying clues about the conditions that existed when the planets were forming. Asteroids also carry fragments of that early time. Meteorites that fall to Earth can contain material older than the planet's surface, small pieces of the early solar system delivered into human hands. Some tiny grains found inside meteorites may even predate the sun itself, formed around older stars before our solar system existed. That fact is almost impossible to hold calmly. There are grains of matter older than the sun. This is another reason our moment is difficult to place. We are not the unavoidable result of the universe. We are one outcome inside a chain of events so long and specific that it almost disappears into vastness. A different nearby explosion, a different cloud collapse, a different early impact, a different orbital arrangement, and the story could have been another story entirely. The universe is old enough to build worlds, but it is also chaotic enough that no world is promised. Earth happened because time allowed it, but time alone did not guarantee it. And still, When we follow the chain backward, the connections are real. The sun needed the galaxy needed earlier structure, the solar system needed enriched gas, Earth needed the disk around the young sun. Life needed a planet that could remain stable long enough for chemistry to become biology. Human beings needed almost everything before them to happen in a certain order, across billions of years, before they could appear for one brief moment and call the universe ancient. It makes it strange. We are living inside the aftermath of events we cannot remember, cannot witness directly, and can only reconstruct through light, chemistry, motion, and traces left in matter. Astronomy is, in this sense, a kind of memory work. It looks at the universe and tries to read the past from what remains. A spectrum of light becomes a chemical fingerprint. A meteorite becomes a fossil of the early solar system. An old star becomes evidence of ancient conditions. A galaxy's structure becomes a record of what gravity has done across billions of years. The universe does not tell its history in words, it leaves evidence, only younger, simpler, darker in some places, brighter in others, and slowly becoming capable of the world we know. That may be the strangest part of all. The universe before the solar system was not a different reality. It was the same reality before our home existed. The same laws, the same gravity, the same matter, though arranged differently, the same long patience, the same indifference. It did not know that one cloud would one day become the sun. It did not know that one small planet would cool into oceans. It did not know that life would look upward from that planet and try to measure the age of everything. But cosmic time does not require knowledge. It only requires continuation. The past continued long enough for the solar system to appear. The solar system continued long enough for Earth to become alive. Earth continued long enough for humans to become aware of the past. And now, standing at this tiny point in the timeline, we can look backward and see that we arrived after an almost unimaginable sequence of change. The universe is not finished because we have arrived. The stars are still moving. The sun is still burning. Galaxies are still changing. The future is not a short ending after a long beginning. It may be longer, stranger, and darker than everything that has happened so far. And once we turn from the ancient universe behind us to the cosmic time ahead, the scale becomes even harder to survive. The past already feels impossible. It contains the first stars, the birth of galaxies, the slow building of the Milky Way, the formation of the sun, the making of Earth, the rise of oceans, the appearance of life, and the entire story of every creature that ever lived before us. It is so large that human history becomes almost invisible inside it. But the future may be even larger. That is the part the mind resists. We are used to thinking of the future as something close. Tomorrow, next year, the next generation, the next century. Even when humans try to think far ahead, we often imagine a few thousand years, or perhaps a few million if we are thinking on the scale of species. Beyond that, the future stops feeling like a place and becomes a blank space where imagination fades. But the universe does not stop where imagination fades. The universe has time ahead of it, more time than the age it has already lived. This does not mean the universe will remain bright, comfortable, or familiar. It only means that what we call the present is not close to the end of the timeline. The Big Bang happened about 13.8 billion years ago, which is already so old that the number becomes abstract. But many of the processes that shape the far future unfold over hundreds of billions, trillions, or even longer stretches of time. Compared with those lengths, the entire age of stars we know now may be only an early chapter. The past is enormous. The future may be deeper. At first, the future can seem almost unchanged. The sun will rise tomorrow. The stars will look nearly the same tonight. Earth will continue turning. The moon will continue moving around us. The planets will continue their quiet paths around the sun. On human timescales, the universe feels stable enough to trust. The great changes are too slow to touch daily life. But this is only because we live inside a very small slice of time. If we widen the view, the future begins to move. The continents will continue shifting. Mountains that seem permanent will erode. New oceans may open. Old oceans may close. Ice ages may come and go. Species will appear, spread, change, and vanish. The world that feels fixed beneath our feet will keep becoming other worlds. Even without any dramatic cosmic event, Earth will not remain exactly as it is. There may not be one final sunset that marks the end of habitability. There may only be a long retreat. The oceans could shrink. The climate could become more extreme. The atmosphere could change. The surface could become harder for complex life to survive. The timeline is still studied and debated in detail, but the larger truth is simple enough. Earth's comfortable age is not permanent. The planet had a beginning as a habitable world, and it will have an ending as one. That ending is not near by human standards. It is unimaginably far away. But cosmic time makes even unimaginable distance part of the story. 1 billion years from now is not tomorrow. It is so far ahead that every nation, language, building, and recorded name from the present will almost certainly be gone. Even the shape of life on Earth, if life remains, may be completely different. The planet may not carry forests, animals, or oceans in the way we know them now. It may still be Earth, but Earth will not necessarily mean home. This is one of the hardest things to accept about time. A place can continue to exist after it has stopped being the place we remember. And even then, the universe will not be finished. That is the part that makes the future truly unsettling. The death of the sun feels like the end, because the sun is the center of our world. But cosmic time continues beyond local endings. The solar system may fade, but the galaxy remains. Other stars will still shine. Red dwarfs will continue burning slowly. New stars may still form for a while in cold clouds of gas. Galaxies will continue changing. The universe will still have structure, gravity, motion, and time. Our ending is not the universe's ending. Even the sun's ending is not the end of the age of stars. Some lights vanish early, others continue. Galaxies lose their brightest blue stars, but dimmer red stars remain. Star formation slows, but existing small stars keep burning. White dwarfs cool. Neutron stars spin down. Black holes wait. The universe becomes less like a brilliant city and more like scattered embers, separated by growing darkness. This is not a future humans can truly picture. It is too large, too cold, too slow. We can describe it, but description is not the same as feeling. The mind tries to imagine 1 trillion years and finds almost nothing to hold. 1 trillion years is not simply many times longer than human history. It is longer than the age of the universe so far, by such a vast margin that even the entire cosmic past begins to feel young. And yet, 1 trillion years may still not be the end. That is where cosmic time becomes almost frightening in its patience. There are futures beyond the future of the sun, futures beyond the fading of many stars, futures beyond the age when galaxies look bright and full. The universe may continue into eras where the familiar ingredients of the night sky are mostly gone, or transformed into remnants. This does not happen quickly. It happens so slowly that words like decay and fading almost become peaceful. But the result is not peaceful in the human sense. It is a universe with fewer new stars, fewer warm worlds, fewer places where complexity as we know it can easily continue. Not because of one violent destruction, but because the universe gradually spends the conditions that make the bright age possible. The stars are not just shining, they are using up the era of starlight. Every new star forms from gas that may not be replaced in the same way forever. Every generation of stars locks some material away in remnants. Every bright phase moves the universe one step farther from the simple abundance of star-forming fuel it once had. Galaxies can recycle matter, but not perfectly. Over immense time, the cosmic supply of easy new starlight declines. But this may be only what the universe is right now. Right now is not a universal concept. It is our slice. The future also changes the meaning of the past. The 13.8 billion years behind us feel ancient because they contain everything we know. But if the universe continues for trillions of years, then the age we live in is not late in the largest possible sense. It may be early. Not early compared with Earth's formation, or the first stars, or the sun's life, but early compared with the total future that may still unfold. Human stories have beginnings, middles, and endings that feel balanced. The universe does not. Its beginning is ancient, its present is temporary, and its future may stretch into lengths that make both the beginning and the present feel small. There may be no neat middle where minds like ours naturally belong. There is only a changing cosmos, and we find ourselves inside one bright, habitable moment of it. This moment is easy to mistake for normal. Stars above, sun by day, moon by night, Earth underfoot, galaxies in deep images, planets orbiting, light crossing space. It all feels like the standard condition of reality. But cosmic time suggests that the universe has many conditions. A hot early state, a dark age before stars, a bright age of galaxies, a future of fading light, a future of remnants, perhaps even longer eras beyond anything we can connect to experience. The bright age may last far longer than human beings can imagine, but it will not remain unchanged forever. The largest stars are already dying quickly. Stars like the sun have limited lives. Red dwarfs will last much longer, but even they are not infinite. Over enough time, the population of living stars will shift. The universe will become dominated by old, dim, and dead objects, rather than new bright ones. The night sky of the far future may not be a sky humans would recognize. If there are observers in that future, around some long-lived star, they may see a darker universe than we do. Distant galaxies may have moved beyond visibility because of cosmic expansion. Star formation may be weaker. The grand river of the Milky Way may have changed through interactions and mergers. Many of the stars we see now will be gone. Their sky may feel lonelier, older, and more silent. Not only the absence of light, but the loss of access to the past. We live at a time when the universe is old enough to contain heavy elements, planets, and life, but young enough that distant galaxies are still visible. Star formation continues, and the cosmic story can still be read in light. This may be a rare kind of moment, not rare in years, because it lasts far longer than humans can grasp, but rare in the total shape of cosmic history. We may live during a window when the universe is visible enough to study itself. That thought gives the present a strange weight. We are not central. We are not the reason the universe exists. But we may exist during an era when the universe can be understood in ways that might not always be possible. The cosmic microwave background is still detectable. Galaxies still fill the deep field. Stars still reveal chemical histories. The evidence of the beginning, the growth of structure, and the lives of stars is still written across the sky. It hides the first stars behind distance and faintness. It hides old impacts beneath erosion. It hides ancient oceans under changed rocks. It hides the past inside signals that weaken as space expands. And in the far future, it may hide entire regions of the universe, beyond horizons that no observer can cross. This means the future is not simply more of the present. It is another kind of universe slowly emerging from this one. The laws may be the same, but the conditions will change. The stars will age, galaxies will merge and fade, the supply of new light will decline. The distance between large structures may grow. The universe will not suddenly become nothing. It will become older, thinner, in usable energy, quieter, invisible change, and filled more with remnants than with young fires. This future is difficult to make cinematic because it is not a single explosion. It is not one final image. It is an almost endless dimming. And that is what makes it powerful. A sudden ending is easier for the mind. It gives fear a shape, a flash, a collision, a final moment. But the universe may not end that way. Its future may be a long fading in which one era slowly gives way to another, and then another, each colder and quieter than the last. The stars do not all go out together. The darkness grows by patience. Cosmic time is patient enough to erase the sky slowly. This is where the title of the journey begins to feel true in a deeper way. Light years break the human mind because distance is too large. But cosmic time breaks the mind because even the largest distance still exists inside a timeline. A galaxy may be billions of light years away, but time decides what it was, what it is, whether its light can reach us, and whether future observers will ever see it at all. Time is not just another measurement. It is the stage on which the universe changes its identity. The universe of the first stars was not the universe of Earth. The universe of the sun is not the universe of the far future. The bright age is not the final form. The stars we see are not permanent residents. The galaxies are not fixed islands. The present is not a resting place. It is a transition so vast that it feels still only because we are so brief. And when we understand that, the future becomes less like a blank space and more like a shadow spreading ahead of everything. Not empty, not meaningless, but enormous, cold, and almost completely beyond human scale. The past made us from stars, the present lets us see the stars. The future will slowly take the stars away. That is the arc, hidden inside cosmic time. And the next part of that arc begins, when the age of new light starts to weaken, when the universe still contains stars, but fewer young ones, fewer bright ones, and fewer places where fresh fires can begin. Long after the sun is gone, long after Earth's familiar story has ended, the last long-lived stars will continue burning in the dark. But even they will not burn forever. That is the thought that makes the far future feel almost unreachable. The longest-lived stars seem, at first, like a way for the universe to avoid darkness. If massive stars die quickly, and stars like the sun live only for billions of years, then perhaps the small red stars can carry light forward almost indefinitely. They burn slowly. They are dim. They spend their fuel with extraordinary patience. They can outlast every bright star visible to the naked eye. But cosmic time is larger than even their patience. A red dwarf can shine for hundreds of billions or even trillions of years, depending on its mass. That is so long that no red dwarf has yet reached the end of its natural life, because the universe itself is not old enough. Every red dwarf that has ever formed is still somewhere in its long journey, unless it has been destroyed by some external event. Their futures belong to a time so distant that the present universe still feels like childhood beside it. And yet, they are still temporary. They are not exceptions to cosmic time. They are only slower examples of it. They too burn fuel. They too change. Their light is faint, but it is not endless. Their cores evolve. Their hydrogen is slowly spent. Their long, calm ages stretch far beyond the sun's life, far beyond Earth's living era, far beyond the galaxies as we know them now. But eventually, even the slowest fires begin to fade. The last stars will not die like explosions across a crowded sky. They will fade in a universe that has already become quiet. By then, the bright stars will be long gone. The hot blue giants will have burned out quickly in the early chapters. Stars like the sun will have expanded, shed their outer layers, and become white dwarfs. Many galaxies will have changed their shapes through mergers and gravitational interactions. The Milky Way and Andromeda will no longer be separate spiral galaxies in the way we imagine them now. Star formation will have slowed as usable gas becomes rarer. The universe will not be empty, but it will be older, colder, and far less alive with new light. This is the beginning of a different kind of darkness, not the early darkness before stars, when the universe was young and waiting for its first fires. This is an older darkness, the darkness after the age of starlight has spent itself. The first darkness was filled with possibility. Gas was gathering, gravity was building. The first stars had not yet appeared. The later darkness is different. It comes after stars have lived, after galaxies have shone, after planets have formed, after worlds have cooled and changed, after countless chances for light have passed through their brightest phase. It is not the darkness before the story. It is the darkness after the long, bright chapter. The last stars will probably not be the great dramatic stars humans notice most easily. They will not be enormous blue giants, because those live too fast. They will not be stars like the sun, because those burn through their stable lives far sooner than the smallest stars. The last natural stars will likely be the smallest red dwarfs, faint and cool, burning so slowly that they carry light into a future almost impossible to imagine. Around them, perhaps, some planets may still orbit. Those worlds would not resemble Earth in any simple way. They would exist in a universe where most other stars are dead or fading, where the night sky is thinner, where the bright structures of the cosmos have changed beyond recognition. A planet around a long-lived red dwarf might still receive warmth, but it would be warmth from a small, dim star in a much older cosmos. If life could exist in such a place, it would belong to an era almost completely disconnected from our own. It would live under the last embers. That image is powerful because it is not violent. It is not a planet being shattered, or a galaxy exploding, or a star tearing itself apart. It is light becoming rare. It is warmth becoming local. It is the universe slowly losing the bright abundance that makes our current sky feel full. When humans imagine the end, we often imagine suddenness, a final impact, a final flash, a last day. But the fading of the stars is not like that. It is spread across timescales so vast that no single observer could experience the whole transition. It is not a moment. It is a direction. Star by star, generation by generation, the universe becomes less capable of making new light. But even that future is not the final edge. After the last small stars finish burning, the universe enters an even quieter phase. What remains are not ordinary stars, but remnants. White dwarfs, neutron stars, black holes, cold planets, asteroids, comets, and matter scattered through space. The bright stellar age becomes memory, not in minds necessarily, but in the objects left behind. A white dwarf is the memory of a star like the sun. A neutron star is the collapsed memory of a massive star. A black hole is a place where gravity has sealed matter into something almost beyond ordinary description. The universe becomes an archive of dead light. White dwarfs will cool slowly. At first, they may still glow with leftover heat, but they no longer shine because of ongoing fusion like living stars. They are embers, gradually releasing the heat of their former lives. Across extreme spans of time, they are expected to fade toward black dwarfs, cold stellar remains that no longer give off significant light. None are thought to exist yet, because the universe is not old enough for any white dwarf to cool that far. That fact itself is almost surreal. There are future objects that should exist, but the universe has not had enough time to make them yet. Cosmic time is not only about the past being deep, it is also about the future being unfinished in ways the present cannot yet show. There are endings that are physically expected but have not occurred anywhere because the clock has not run long enough. The universe is still too young for some kinds of darkness. For most of the cosmic history we can imagine easily, stars are the main characters. They light galaxies, they build elements, they shape planets, they give energy to life. They create the familiar contrast between light and dark. But when the last stars fade, the main characters change. Gravity remains. Remnants remain. Black holes remain. Cold matter remains. But the era of ordinary stars begins to close. And this closure does not need an audience. That is one of the most difficult parts to accept. Humans often frame the universe as something being seen. A sky above us, a view through a telescope, a documentary, a journey. But cosmic time does not require observers. The last stars may fade without anyone watching. The final red dwarf may cool in silence. The last planet, warmed by starlight, may freeze under a sky with almost no visible companions. The universe can continue changing even if there is no mind left to describe it. This is not meant as a simple, depressing thought. It is larger and quieter than that. It means that the universe's story is not built around witness. Witness is something that can appear inside the story for a while. Eyes open on a planet. Instruments are built. Light is measured. Questions are asked. Then, perhaps, witnesses vanish. The timeline continues. Cosmic time does not pause for meaning. It carries meaning for a while, when meaning exists, and then it moves beyond it. And still, before that deep darkness, there is an almost unimaginable stretch of remaining light. That is important. The last stars are not near. Their fading lies so far ahead that the sun's entire remaining lifetime is only an early part of the road. Earth's future, the death of the sun, the fading of bright stars, the slowing of star formation, all of this happens before the deepest stellar twilight. Cosmic time does not rush toward the dark. It takes the longest possible path there. That slowness is what makes the subject so difficult. A sudden disaster can be pictured. A slow fading over trillions of years cannot. It does not fit into emotion easily. It is not grief because it is too large. It is not fear because it is too distant. It is not peace because the ending is still real. It sits somewhere beyond normal feeling, as a kind of quiet, cosmic dread. The last stars make us realize that even the universe's beauty is temporary. The Milky Way's glow is temporary. The bright blue stars are temporary. The golden light of stars like the sun is temporary. The red dwarfs are temporary. The era when the universe is full of shining suns is temporary. This does not make the beauty false. It makes it more precise. It belongs to an age. We see it because we live during that age. We are creatures of the stellar era. Everything about us is shaped by that fact. Our eyes evolved under a star. Our sleep follows a planet's rotation under a star. Our food comes from sunlight. Our seasons are the rhythm of a world orbiting a star. Our myths, calendars, navigation, science, and deepest images of the cosmos all come from living during a time when the universe is still bright enough to be read. The last stars are not simply future objects. They are markers of the end of the conditions that made our kind of cosmic view possible. When they fade, the universe does not end, but the universe of stars ends. The universe that made night skies, sunrises, habitable zones, glowing galaxies, and stellar nurseries becomes a memory written in remnants. There may still be black holes. There may still be cold planets. There may still be particles moving through vast darkness. There may still be time, but time after starlight is not time as we emotionally understand it. It is almost beyond story, because stories need change that can be followed, and the far future becomes slower, colder, and more silent with every step. That is where the human mind begins to lose its grip again. We can say, the last stars fade. The words are simple, but the reality behind them is almost impossible. Trillions of years of stellar history, countless suns born and gone, galaxies dimmed, worlds frozen, remnants cooling, and light becoming rare in a universe that once seemed full of it. A sentence can hold the idea, but the mind cannot hold the scale. And perhaps that is the real meaning of cosmic time. It is not only that the universe is old, it is that its oldness contains phases we are not built to imagine. A beginning without stars, a bright age full of galaxies, a future of fading suns, a deeper future of remnants. We stand in one brief illuminated part and try to understand the whole. But the whole is larger than the kind of time our minds evolved to use. The last stars show us the far edge of the age we belong to. Not the end of all existence, but the end of the familiar cosmic world. The world of stars as sources of light, warmth, chemistry, and possibility. The world where a planet can look up and see a sky filled with suns. The world where a species can trace its atoms back to stellar fire and still live under a star of its own. When that age ends, the universe continues into something harder to name. And this brings us close to the final question of the journey. We have followed time backward to the first stars and forward to the last ones. We have seen that Earth arrived late, that the sun is middle-aged, that stars are temporary, and that the future may stretch far beyond the age of light. The scale is no longer only large, it is almost hostile to ordinary understanding. Because the human mind was not built for this. It was built for days, seasons, danger, memory, and the short lives of living things. It can count billions and trillions, but counting is not the same as understanding. Cosmic time asks the mind to hold the birth of stars, the death of stars, the making of planets, the fading of galaxies, and the possibility of darkness so far ahead that even the universe we know may become an ancient, vanished phase. And that is where the last part of this journey has to go. Not farther into the future and not deeper into the past, but inward, into the strange gap between what the universe is and what the human mind can survive understanding. Because cosmic time is not only difficult because the numbers are large. Large numbers alone do not break us. We can write them down. We can say billions, trillions, quadrillions. We can place them on a screen, compare them, measure them, and build scientific models around them. In that sense, the mind can handle the numbers. But understanding is not the same as reading. A human mind did not evolve to feel 1 billion years. It evolved inside days, seasons, hunger, danger, weather, memory, and the short lives of living things. It learned to understand time through sunrise and sunset, through the changing of the year, through childhood becoming adulthood, through the aging of faces, and through the loss of people it once knew. Those are the clocks we are built to feel. The universe uses different clocks. Stars burn for millions or billions of years. Galaxies change across spans that make all of human history feel like a flicker. The sun can seem permanent for every generation that has ever lived and still be only halfway through its life. Earth can hold mountains, oceans, and life for ages, and still be a temporary condition under a changing star. The first stars can vanish before our planet is born. The last stars can fade after almost everything familiar has disappeared. The human mind tries to place itself somewhere inside that scale, and it fails quietly, not because we are unintelligent, but because we are local. We are creatures of a planet. Our senses are tuned for nearby space and short time. We can notice a shadow moving, A storm approaching, a face changing, a season turning. We can remember years, imagine decades, and study centuries. With effort, we can think about millions of years. But cosmic time does not stop there. It keeps going until the difference between 1,000,000 years and a human lifetime becomes almost meaningless beside the deeper numbers. This is what makes the age of the universe so unsettling. It does not simply tell us that we are small. Space already tells us that. It tells us that almost everything we think of as solid and lasting is only a phase. A planet is a phase. A star is a phase. A galaxy's bright appearance is a phase. Even the age of starlight is a phase. That word is quiet, but it changes everything. A phase is not unreal. It is not unimportant. It can last longer than any human idea of permanence. But it is not final. It belongs to a sequence. It has conditions that allow it to exist, and those conditions can change. Human life happens inside one phase of Earth. Earth happens inside one phase of the Sun. The Sun happens inside one phase of the Milky Way. The Milky Way happens inside one phase of the universe. Each level feels stable from within, because we live too briefly to watch the whole transformation. This is why the night sky is so powerful. It looks calm enough to fall asleep beneath, and yet it is full of objects moving through lifetimes too large for us to witness. The stars appear as tiny lights, but each one is a process. Each one has a beginning hidden in gas and dust, a long period of burning, and some eventual transformation. Some will die violently, some will fade slowly, some will leave behind white dwarfs, some will collapse into neutron stars or black holes. Some small stars will keep burning long after the sun is gone. The universe is not still. It is slow, and slow can be more frightening than sudden violence, because it removes the idea of escape. A disaster can sometimes be avoided. A storm can pass. An impact can be imagined as one event. But cosmic time is not an event. It is the condition in which every event happens. It is the river carrying stars, planets, and galaxies from one form to another. There is no place outside it. This is why the age of the universe can feel heavier than distance. Distance separates us from other places. Time separates everything from itself. The Earth that existed before life is gone, even though the planet remains. The Earth of the dinosaurs is gone. The young sun is gone. The first stars are gone. The future sun has not arrived yet. The last stars are not here yet. Every object is always becoming a different version of itself. Even now, a mountain seems still, but it is eroding. A continent seems fixed, but it is moving. The moon seems constant, but it is slowly drifting away. The sun seems identical to yesterday, but its core is changing. The stars seem fixed, but they are aging and moving through the galaxy. The universe seems like the background of our lives, but it is not a background. It is the largest process there is. Cosmic time breaks the human mind because it forces us to see that our present is not the main stage. It is one frame inside a film too long to watch. Too early in the universe, and there may not have been enough heavy elements for rocky worlds like Earth. Too early in the solar system, and Earth was molten, violent, and not ready for life. Too late in the sun's future, and Earth may become too hot, too altered, too hostile. Too far in the future of the universe, and the bright cosmic view we know may fade into something darker and more isolated. We live during a window. A long window by human standards, but still a window. Inside that window, the universe is old enough to remember itself through evidence. The cosmic microwave background still reaches us. Distant galaxies are still visible. Stars still reveal the chemistry of older stars. Meteorites still carry clues from the beginning of the solar system. Earth still keeps traces of its past in rocks, fossils, isotopes, craters, and layers. The universe is readable, at least partly, because we live at a time when its evidence has not vanished completely from view. That may be one of the quiet miracles of our era. Not that the universe exists for us, but that we exist during a time when some of its story can still be seen. That is not how the mind naturally works. So we live with two truths at once, the human truth and the cosmic truth. The human truth says that a lifetime is long, a childhood lasts forever, while it is happening. A year can change everything. 100 years can hold entire worlds of memory, invention, war, love, loss, and change. To us, these are not small things. They are the scale on which meaning exists. The cosmic truth says that all of human history is a thin mark at the edge of a much older timeline. Earth was old before humans. The sun was old before Earth became alive in the way we know it. The galaxy was old before the sun formed. The universe was already deep in its story before there was any planet here to call home. Both truths are real. It is rare by condition. At least as far as we know, the universe does not understand itself everywhere. Stars do not know they shine. Galaxies do not know they rotate. Rocks do not know they are old. The sun does not know that Earth orbits it. But on this planet, for a brief time, matter became aware enough to measure the age of stars. Ancient atoms gathered into living minds, and those minds turned back toward the darkness that made them. That does not make humans the center. It makes the moment unusual. It is a position. Our position. Cosmic time breaks the mind because it refuses to fit inside human scale. It tells us that the universe is not young, not still, not built around our pace, and not finished with change. It tells us that our world had a long before, and will have a long after. It tells us that the lights above us are not eternal ornaments, but temporary fires. It tells us that even the brightest age of the universe is only one chapter. But it also gives the present a kind of quiet power, not because we are special, but because timing is everything. The universe had to become old enough for rocky planets. Earth had to remain stable long enough for life. Life had to survive long enough for minds. Minds had to become curious enough to build instruments. Instruments had to become powerful enough to look backward through light. And now, from one small planet around one ordinary star, we can speak about the first stars and the last stars in the same breath. That is the strange beauty of the human moment. It is almost nothing in duration, and yet it can contain an image of everything. When we say the universe is 13.8 billion years old, we are not simply naming a number. We are pointing toward a chain of transformations so large that every part of our world is caught inside it. The atoms in our bodies, the heat of the sun, the rocks of Earth, the darkness between galaxies, the red glow of old stars, the faint light from the early universe. All of it belongs to time. Time is not just something the universe has. Time is one of the ways the universe becomes. It becomes simple matter. It becomes stars. It becomes heavier elements. It becomes planets. It becomes oceans. It becomes life. It becomes minds. It becomes questions. And far ahead, it becomes fading stars, remnants, darkness and forms of existence that may no longer resemble the universe we know. This is why the title is not only about age. It is about scale. Cosmic time does not break the human mind by being old in one direction. It breaks the mind by stretching in both directions at once. Behind us, a past too deep to feel. Ahead of us, a future too long to imagine. Around us, a present that feels solid only because we are living inside it. The present is real, but it is not permanent. And maybe that is the final quiet terror of the universe. Not that everything vanishes instantly, but that everything changes eventually. The most familiar light, the most stable world, The oldest sky, the grandest galaxy. Nothing needs to rush, nothing needs to attack. Time only has to continue. For a human being, that can feel unbearable. But it can also feel strangely calming. We are not required to hold the whole thing. We cannot. No mind can truly feel 13.8 billion years, or a trillion years, or the fading of the last stars. We can only approach it in pieces, through stories, images, measurements, and quiet nights under the sky. And perhaps that is enough. Enough to understand that we live in a universe far older than our instincts. Enough to understand that stars are temporary fires in a long darkness. Enough to understand that Earth is not the beginning of the story, and not the end. Enough to understand that our moment is brief, but real. Tonight, the stars above us still shine. The sun is still in the calm middle of its life. Earth still turns. The universe is still readable. Light from ancient galaxies still reaches us. The deep past is still written across the sky. And somewhere far ahead, beyond the sun, beyond Earth's familiar future, beyond the last gentle red stars, time continues into a darkness no human mind was built to hold. That is cosmic time, the age that breaks the human mind. Thank you for watching this journey into cosmic time. If you enjoyed this calm exploration of the age of the universe, subscribe to the channel for more space documentaries like this. Leave a like if you want more deep journeys into the mysteries of time, distance, and the universe. And write in the comments what impossible space mystery you want to explore next. Tonight, you were watching the Space for Sleep channel, talking about cosmic time, the age that breaks the human mind. Sleep well, and keep looking up. Good night.